minus the top times the derivative of the bottom divided by bottom squared. Okay. That's the quotient rule. It is possible to turn basically every quotient you ever come across into a product. Right? For example, we'll do this in two different ways. Let's say you have the function h of x equals x squared minus 3 over x plus 1. So you had that. You want to find the derivative. Okay, I'll follow my formula. I've got an upper function f, I've got a lower function g. So to use the quotient rule first, that we just introduced here, so then I should take the bottom h prime of x. Yes, I am switching between notation as get used about. H prime of x is x plus 1, right? The bottom times the derivative of the top. The derivative of the top is 2x minus the top, x squared minus 3, times the derivative of the bottom. Well, it's 1 over the bottom squared. X plus 1 squared. A common pitfall that most people think for at least a brief moment is that, well, you know what I'll do here? I'll cancel this x plus 1 with this x plus 1, and I'll proceed from there. But why can I not do that?
Bottom squared.
Say again?
Bottom squared.
No, that's not the problem. The problem is that this term here does not have an x plus 1. Every term would have, these are three terms, this one, and that one. Every term would have to have the x plus 1, right? I can't just take it from one of the terms above. I have to go from all of them. All right. So now you just want to simplify the numerator. So what do we have? 2x squared minus x squared is an x squared. 2x, I guess all we have now is a plus 3. Plus 2x plus 3 over x plus 1 squared.
Now we factor it.
Factor what, the top?
Both of them?
Well, this was already factored. You can try to factor the top if you want.
Yeah.
Go ahead and try.
Let's see.
X plus 1 is squared times.
Go to the formula. The formula has the square of the bottom in it. Right? The formula itself has the square of the bottom in the bottom. Right? So you should see that this is not factored into integers. This is not x plus 1, x plus 3, right? Or any other combination of integers. Okay? So this is your reduced form right here. Right? It is something to note, though, that if the top and bottom had a common factor, it would be a good idea to reduce that. Yep?
Should you not multiply the bottom by itself and get x squared minus 1? Should you leave it like that?
So you're saying multiply this out to get x squared plus 2x plus 1? No, leave factored. Always leave. Anytime you have something factored in a derivative formula, leave it factored. Factorization is the most important form for it to be in. Multiplying out will obscure what's going on. You'll see what I mean later. Any question about quotient rules so far? So how could you change this to a product? If you have a quotient here, let's say this. You hate quotient rule. You're one of those people. You just hate quotient rule. How could you change it to a product? That's right. I could write this as x squared minus 3 times x plus 1 to the negative first. Now I'm multiplying two things together. Okay? Problem is we haven't learned yet, we will tomorrow, how to deal with this little case here. I have a function put inside another function. I've got an x plus 1 put inside the inverse function here. So chain knows chain, right? Chain knows the chain rule. Is that what we said? Okay, so we'll have a chain rule tomorrow. So just note that every quotient can be made into a product, and by the end of tomorrow, we'll know how to deal with those cases should you never want to ever use the quotient rule. All right? It's your business. But it's there for those who aren't afraid of division. Any questions? There's one more special case we introduce in this section. You want to do another quotient rule, or you're okay with that? Quotient rule has been exhibited succinctly enough? All right? So there is a special case of the chain rule that Chan just mentioned that they introduced in this section. It's a very special case. That is, that your function is e, not to the x this time, but to a multiple of x, e to the kx. Okay? This is the small example we want to bring before we introduce chain rule proper. So the derivative of this is k e to the kx. They would like to introduce in this section slightly more complicated exponential functions. Not just e to the x, but e to the something times x. So if you had f of x equals e to the 6x, then the derivative is simply going to be 6 e to the 6x. Okay. So the way to the proper way to think about this result is not that the number 6 comes down like the power rule. This is not a power rule whatsoever. Okay? The proper way to think about it, especially for tomorrow, when we talk about the chain rule, is what you're really doing here is you are taking the derivative of e to the 6x. If it were just the regular exponential function, it would come back exactly how it was, right? E to the x comes back as e to the x, okay? So I get this piece back again, the exact same thing, because that is the derivative of an exponential function. And then I take the derivative of what is inside. I take the derivative of 6x and I multiply by that. That is the way you want to think about this small little guy here, okay? And we'll have a vast array of other derivatives and functions we're going to apply that same logic to next time, correct? Then it is the derivative of the outer function times the derivative of the inner function. So e to the 6x comes right back. You take the derivative of what's inside. The derivative of 6x is 6, and you multiply that to the outside. That is what chain rule is. And this is just a very specific example of what's called a chain rule. Again, we'll talk more about that tomorrow, right? But that's the proper way to think about it. So now let's say we have one more quotient. I don't want to punish you. Let's see what we got here. Number 21. Probably too easy for you guys. Too easy. Since we did two products, I want to do two quotients. E to the x over x squared minus 1. Gx is e to the x over x squared minus 1. Baker. Baker, right?
Yes.
I want to apply a quotient rule to this thing. So g prime of x is, what's the first thing we're going to do? What's this thing look like? What goes here?
X squared minus 1.
Man. Baker, are you a ventriloquist?
Huh?
Are you a ventriloquist?
Am I being trouble?
Yeah. Ventriloquist?
What is that?
The guy who holds the puppet.
A ventriloquist is a voice thrower.
Puppet master.
He throws his voice. He makes it sound like some voice,
Yeah.
which is his, may not sound exactly like it, comes out of some other location.
Yeah.
That's a ventriloquist. He usually do with puppets. He doesn't just do puppets. He's not like the Muppets, where he's like below the stage and the Muppets are just like
no,
above.
like the guy who's
He-
holding.
Yeah, he's holding
Yeah,
it.
he's
Yeah,
fine.
he's
Yeah, and he
holding
makes
it, and
his
like,
mouth
the
doesn't
guy's
move, but it makes it
talking,
look
but
like
his
the
lips are,
puppet.
like,
He throws his voice to the puppet mouth.